This video will give you information on ionic bonding and how to write salt formulas. We are first going to look at what an ion is versus a neutral atom. Here I have a drawing of an aluminum atom that is neutral in charge. You'll notice in the center of my atom is the nucleus, which is this is the nucleus. And I have some shorthand written in here, and what this tells us is that aluminum is made up of 13 protons and 14 neutrons, which I can determine from my periodic table based on the atomic number and the mass number. Around it I have electron shells, which contain electrons. In the first shell there are 2 electrons, which is denoted by this 2e-. In the second shell there are 8 total electrons, which is denoted by this 8 electron. And in the last shell there are 3 electrons, which is denoted by this 3e-. This is a neutral aluminum atom. It is a solid metal in its physical form. And we know that it is neutral because the number of protons, 13, equals the total number of electrons, which is also 13. In neutral atoms, the number of protons equals the number of electrons. In our aluminum atom here, we have 13 protons and 13 electrons. Together, that would be 13 positive charges and 13 negative charges. And if we add those charges together, we get a total charge of 0. That's how we know it's neutral, no charge. In contrast to that, we have our aluminum ion, which has a 3+ charge. The nucleus of ions never changes. The amount of protons in an ion will never change, or else you will change the identity of the atom. What does change, however, for an ion is the amount of electrons. You can see here that I still have the first shell of electrons with 2 electrons, and the second shell of electrons, which has 8, but I'm missing the third outer shell of electrons that would have 3 electrons. That is gone. And because it is gone, the amount of protons we have no longer equals the amount of electrons that we have. And that's how we get an overall charge on an ion. So in an ion, the protons do not equal the number of electrons. Remember that when making ions, the only thing that can change is the number of electrons, or else you change the identity. So only change electrons. Otherwise, you change what it is. Negative ions are known as anions, and they are made up of non-metals. Positive ions are known as cations, and they are made up of metals. If we look at our periodic table, we can determine the charge of any ion. So here's your periodic table, and I would like to bring your attention to some numbers that are on it. These numbers at the top of each column tells you the charge for all of the elements in that column. So let's look at the first column. Everything in this column here can be neutral or +1 charge. That's it. Those are the only options for everything in this column. Sodium will form a 1+ ion, or it will be neutral in charge. Potassium will form a 1+ ion, or it will be neutral in charge. In our second column, the options are 0 or +2. That means everything in this column can be 0 or +2 in charge. Beryllium can be +2 ion. Magnesium will only ever be a +2 ion. Calcium, +2 ion. Those are the only possible charges as ions. They can also all be neutral. We're going to skip over this center block for a minute because you'll notice they don't have numbers up here because they are special. Over here, we get the 0 + 3 column, and we're really mostly going to focus on aluminum in this column. Fourth column has a question mark. In general, the elements in this column do not form ions. They do a different type of bonding, which we will learn about later. Then we start going the opposite direction. We get to 0 or -3. Everything in this column will form a 0 or -3 charge. When nitrogen forms bonds as an ion, its ion will have a -3 charge. Then we have oxygen and sulfur. This column, -2 or 0. And then the last column, we have 0 or -1. These are the ions that it can form. And then over here, no ions will form from these all the way on the right. So that is how you find the charges of ions on your periodic table. Before we do an example, I want to talk about what a salt is. You may know salt as the thing that you eat, but in reality, the salt that you eat is known as table salt. That is sodium chloride. In reality, salt in chemistry refers to all ionically bonded compounds. Any combination of a metal ion and a nonmetal ion is a salt. And these form what is called an ionic bond. An ionic bond forms because there is an attractive force between the oppositely charged ions. When you put two oppositely charged ions together, they will be attracted to each other and they will form an ionic bond, and it's quite a strong bond. All right, so let's do an example of how to do an ionic bond. Let's say we have calcium and oxygen. The first thing to do when you are doing ionic bonding salt formulas is to find out what the charge is of each of your ions. Because we're doing salts, these will be ions. They won't be neutral. We go up to our periodic table and I see calcium 0 or plus 2, so I'm going to choose plus 2, and oxygen is 0 or negative 2, so I'm going to choose negative 2. The charge for a salt is always written in the upper right-hand corner, known as a superscript, like that. The essential thing in making salt formulas is that they come together to make something neutral. They combine to be neutral. I'm going to draw this as bubble pictures, and that is how I want you to do your drawings. So you draw a circle, put the charge, make sure you put the charge in it. The bubble pictures should always have the charges. And you draw it right next to the other ion, taking care that if you have multiples, that the positives only ever touch the negatives. The overall charge of your salt should always be 0. If it's not 0 in a 1-to-1 ratio like I have right now, then you need to add more positive or add more negative. Here, my 2 plus and my 2 minus cancel each other out to be 0, so this is a 1-to-1 ratio salt. When you're writing salt formulas, you always do the metal first and the nonmetal second. The salt formula should never have charges in it because overall it is neutral, and you write it with the symbols. So it would be CaO. And then we have to name it. Naming convention follows the order of salts. So the metal always gets named first, and that remains unchanged. The nonmetal, that are singular elements like we have here, just oxygen, you change the ending to "ide." So calcium oxygen would actually end up being calcium oxide, where the ending gets changed to IDE. And that applies to all of our singular elements. All right, let's try and do one more that is a little bit more complex. Let's do sodium and nitrogen. If we look at our periodic table, sodium has a +1 charge. When it's a +1 charge, you don't have to write the 1. And nitrogen is 3-. I'll start with a 1-to-1 ratio. But you'll notice here that if you add +1 to -3, you'll end up with -2. And this is not 0. I need to get this -2 overall charge down to 0, and I can only do that by adding positives. So to do that, I hope you notice that you need to add 2 positive charges. I'm strategically placing my positive charges so they are only touching the negative charge. Positives should not touch positives, negatives should not touch negatives. Next, I need to write the salt formula. This is where you have to account for how many of each ion that you are using. In my salt formula, I am using 3 sodium ions, so I need to tell people that in my salt formula. Start with the symbol. Always start with the metals. And then, however many of that ion you are using becomes a subscript, like this, Na3. And then I only have 1 nitrogen, so it would be N. And the name of my salt is sodium nitride. You change the ending to IDE. So very quickly, our endings would be nitride, oxide, fluoride, chloride, bromide, iodide. phosphide, and sulfide. Those are the endings that you will see for our nonmetals. Remember, the metal does not get changed. All right, you should be able to do your salt formulas now.